Hello, I am Dr. Rakesh Sancheti, Associate Professor in Department of Chemistry, SNJB's Arts, Commerce and Science College, Chandwad. Today I am going to discuss the topic of F.Y.B.Sc class, that is periodicity and periodicity. So, to understand the periodicity, one has to understand the periodic table, and this periodic table was discovered by Dmitry Mendeleev. He received the Nobel Prize for the discovery of the periodic table. Periodic table is a table in which elements are arranged according to their increasing atomic numbers. Periodic table contains some vertical columns. They are called as groups, and there are total 18 groups in the periodic table. Like groups, there are some horizontal rows. They are called as periods. There are 7 periods in the periodic table. Now, the modern periodic law is that the properties of elements are the periodic functions of their atomic numbers. Modern form of the periodic table is known as long form of the periodic table. The elements which are placed in the same column or groups because they have the similar chemical and physical properties. This image indicates the periodic table. On the right side there is S block. In the middle of the S and P block there is D block, and at the left corner there is the P block. At the bottom there is F block containing 2 series. Let us elaborate the information of the periodic table or classification of the elements in the periodic table. So, there are 4 blocks in the periodic table, all of you know that. First is S block element, second is P block element, and third one is D block, and last one is F block elements. Let us understand why the elements are kept in the S block elements and what is the classification of S block elements. So, the elements, their last electron placed in s orbital or outermost s orbital are known as S block elements. Means the outermost electron if placed in s orbital, then such elements are called as the part of S block elements. S block elements having 2 groups. Group first, that is alkali metals, having a general electronic configuration NS1. Group second are called as alkaline earth metals, having a general electronic configuration NS2. Next is P block elements. So, again the same thing, the last electron if is in p orbital of any element, then those elements are included in P block elements. P block elements having a groups like 13, 14, 15, 16, 17 and 18, and having 1, 2, 3, 4, 5, 6 electrons respectively. The general electronic configuration for P block is written as NS2 NP 1, 2, 6. Now, next is D block element. As I discussed earlier, D block is placed in between S and P block. D blocks contain the group range from 3rd to 12. These elements are also called as transition elements. D block elements are also called as transition elements. The penultimate means inner to outermost, that is n-1 d orbitals are progressively filled from left to right in the period or in periodic table, while NS shell, that is outermost orbital, is filled. In short, elements in which last electron enters in the d orbital of their last but one penultimate shell. So, in short, the elements in the D block are included having the last but one shell is progressively filled, and that last but one shell is called as penultimate shell. Such elements are called as D block elements. General electronic configuration for d block elements can be written as n minus 1 d1 to 10 ns1 to 2. Now, d block consists of the 3 rows, first, second and third rows. First series or row is called as third transition series elements, contains the 10 elements, they are ranging from scandium to zinc. Second transition series is called as 4D series, 4D transition series. Again it contains the 10 elements from yttrium to cadmium. And third series is called as 5D transition series. It contains again 10 elements from hafnium to mercury. After the d block, at the bottom of the periodic table there is a block elements. Again same thing, the elements in which the last electron enters in F orbital and their atoms are called as F block elements, means those elements in which the last electron enters in F orbital or such elements are included in F block elements. Like in transition series elements, the F block elements in which last electron enters in anti-penultimate shell. Anti-penultimate shell means third to outermost, means from outermost shell the inner third shell, from that the count, if we counting started. So, from the outermost shell is third to outermost shell, that is anti-penultimate shell. It consists of 2 series again, one is the 4f orbital series and another one is 5f orbital series. So, this is what the general classification of the periodic table and their elements in the 4 blocks. Now, next important concept is shielding or screening effect and effective nuclear charge. Now, on your screen there is a one diagram that depicts at the center there is a nucleus and there are 2 shells, n is equal to 1, that is the first shell and second shell, and in the shells there are representation of electrons. So, the shielding effect means what? We know that atom contains the multi electrons. So, these electrons in the shell between nucleus and valence shell means outermost shells. So, electrons between nucleus and valence shell are called as intervening electrons, means the electrons between nucleus and outermost shell. So, in between whatever the electrons present are called as intervening electrons. Now, what these intervening electrons did? So, these electrons reduce the force of attraction between nucleus and outermost shell electron. So, we know that nucleus having positive charge and electrons having negative charge, and in the positive and negative there should be the force of attraction, but in between there are electrons, means in between the nucleus and outermost shell there are electrons, these are called as intervening electrons. So, these intervening electrons reduces, means minimizes force of attraction between the nucleus and outermost electron. So, the reduction produced in the force of attraction due to the presence of intervening electrons is called as shielding or screening effect. So, this reduction of force of attraction between the outermost shell electrons and nucleus is called as shielding or screening effect, that is clear cut shown in the diagram that outermost electrons and inner electrons, they have the repulsion, and this repulsion reduces the force of attraction between outermost electrons and nucleus. So, this reduction, in simply we call this reduction of force of attraction is called as shielding or screening effect. Now, with the decrease in force of attraction causes by the shielding of the intervening electrons, the actual nuclear charge is a decrease. by the quantity of sigma, that is screening constant value. The decrease in nuclear charge which is obviously equal to Z minus sigma is called effective nuclear charge and denoted by Z effective. Now this formula of effective nuclear charge is given, that is Z effective is equal to Z minus sigma, or Z effective is equal to Z actual minus sigma. Now let us illustrate this, but before illustrating or calculation of the effective nuclear charge and sigma, let us understand factors affecting magnitude of sigma and Z effective and their variation in periodic table. So there are following factors, they can affect the value of sigma and effective nuclear charge as follows. Number of intervening electrons. Greater the number of electrons present between nucleus and outermost shell, more will be the magnitude of sigma, and hence magnitude of effective nuclear charge will be decreases to the greater extent. When we move down the group, the intervening electrons increases and hence magnitude of sigma also increases. This increase in value of sigma also decrease the value of Z effective. Thus going down the group, magnitude of Z effective goes on decreasing. So number of intervening electrons affect the value of sigma and Z like this. Now second parameter that affects the effective nuclear charge and sigma, that is size of atoms. With increase in size of atoms, Z effective decreases. As the size of atom increases, the effective nuclear charge value decreases. The size of atom increases down the group, at the same time Z effective decreases down the group. Since the size of atom decreases across the period, which increases the effective nuclear charge across the period. Now how to calculate the sigma and Z effective value? By using a Slater rule. The value of sigma for an electron which are present in the s and p orbitals of nth shell of atom or ion in the is the sum of following contributions. Means what are the rules to calculate the sigma value and Z effective value? So let us see the contribution of electrons. Each of the remaining electron in the nth shell make the contribution of 0.35 to the value of sigma. Means count the 0.35 value for the electrons which are in nth, means last shell. Each of the electrons in the n minus 1 shell, means penultimate shell, makes the contribution of 0.85, and each of the electron in the next inner shell makes the contribution of 1. There will be no contribution to the value of sigma by the electron residing in, or means electron present in orbitals having a higher value of their principal quantum number than the electrons for which sigma being calculated. We will see some examples, but in short, sigma for electron residing ns and np orbital can be calculated as 0.35 into number of electrons remaining, or number of remaining electrons in the nth shell, plus 0.85 into number of electrons in n minus 1th shell, plus 1 into number of electrons in the inner shells. Let us elaborate this with some examples. In your examination, such a calculation of sigma and effective nuclear charge can be asked for 2 marks. So let us take an example. So question can be asked like this: calculate sigma and Z effective for 4s electron of manganese having atomic number 25 or copper having atomic number 29 and potassium having atomic number 19. Let us calculate sigma value for manganese for 4s electron shell only. So, electronic configuration of manganese is as 1s2, 2s2, 2p6, 3s2, 3p6, 3d5 and 4s2, means outermost shell is what? 4s shell. So, let us calculate as per the Slater rule that we discussed earlier in this slide. 0.35 into number of electrons remaining in 0.35 into number of remaining electrons in the nth shell, plus 0.85 into number of electrons in n minus 1th shell, plus 1 into number of electrons in inner shell. So, we are discussing here example of manganese, and for what electron we have to calculate the value of sigma and Z effective, that is 4s. We already discussed the electronic configuration of manganese. Now, let us see the calculation. Sigma for 4s electron in manganese atom, for that we have to use the factor 0.35. So, 0.35 into number of remaining electrons in 4s orbital plus 0.85 into number of electrons in 3s, 3p and 3d orbitals plus 1 into number of electrons in inner shell orbitals. Now, I already shown the electronic configuration in the groups. The 4s shell that I shown here separately, the n minus 1th shell electrons I showed it separately, that is 3s2, 3p6 and 3d5, and inner shell group of orbitals and their electrons are shown separately, that is 1s2, 2s2, 2p6. Now, let us fill these values. So, 0.35 into 1, because only one electron remains in what? 4s shell, because we are calculating sigma value and effective nuclear charge for one of the electron of 4s shell. Now, 0.35, that is why we are taking one electron, 0.35 into 1, 0.85 into 13. How these are the 13? Means the 3s2, 3p6 and 3d5, they are collectively 13 electrons, and 1 into 10. Why I am taking 10 number of electrons here? Because 1s2, 2s2, 2p6, these are the inner shell electrons and they are totally 10. So, 0.35 into 1 plus 0.85 into 13 plus 1 into 10. So, the value is what? 0.35 plus 11.05 plus 10. So, sigma value for 4s electron in manganese atom is totally, by doing summation of above these three values, it is totally 21.40. So, sigma value is what? 21.40. This is very simple, you can understand this. Once you know the sigma value, by using a formula of Z effective, that is effective nuclear charge, we can calculate the value of effective nuclear charge. So, we get here sigma value 21.40 and Z minus effective nuclear charge is what? Z minus sigma, and Z means what? Atomic number. Z ka asto, it is atomic number, that is 25. 25 minus sigma, that is 21.40. So, it is 3.60. So, effective nuclear charge for manganese is 3.60. So, in this way you can calculate the sigma value for copper as shown on the screen, and Z effective nuclear value is also, and at the same time you can calculate the sigma value and Z effective means that is effective nuclear charge value for potassium also, that is illustrated here. So, with this we stop this topic here, and in next topic we will see the next periodic properties, that is atomic radii, atomic radius, etc., etc. So, thank you for listening.